Well, good day, fellow steam enthusiasts. And today, on our amateurish low production value videos, we're going to be discussing the Spence pressure regulator. This is a piece of steam heating equipment that not many of you may be familiar with. There are other videos on this type of heating equipment. And this one's mine. Get a look at it there. Now, Spence has been around since the 20s, and they're still around, and they are mostly found, as far as steam heating is concerned, on systems with district steam heating. I think you've seen a couple of videos on my channel consisting of this piece of equipment. And here is one of their catalogs. Getting harder to find these on these actual documents. Most things they stopped printing them, and Spence pretty much doesn't want to answer the phone and deal with mere mortals like myself. So this is what we've got. It consists of two basic parts. You have your main valve here, which is normally closed, and you have your pilot control valve, which receives all of the various inputs and open and closes the main valve as needed. This is the sequence of operation here. As I said, you got the main valve is normally closed. On placing the regulator in service, initial pressure fills the passages as shown in red. So there's the inlet there, and it enters where my finger is, and this chamber here is filled with steam, and it's normally closed because the spring here pushes down on this disc and on this diaphragm, and the steam itself pushing down on this disc keeps it closed. So unless there's debris here, which I've seen in the past, a bit of chunk of something gets caught in there and keeps this from closing, this will normally be closed, and there shouldn't be any downstream pressure here. The steam also enters this 1/4 inch connection into the pilot control. Pilot receives initial pressure through nipple and union connection. There we are. And it enters into this chamber here. I think you can see the remains of the screen to keep out the googies, and the spring or other contraptions. There are other various means of applying pressure here, but this one is a set spring that you can control by adjusting this, and there are various tensions of spring. There's various colors which denote the various pressures that this operates at. And this spring pushes down here and keeps this open. And so the steam then enters this chamber. Let's see, so it goes from here into this chamber and out through this T here, which is a 1/8 inch by 5/16 by 5/16 compression. And this is not 1/4 inch, it's not 3/8, it's 5/16. And so the steam has two places it can go. Down here Now, normally this would not be here. This is only on this valve. This came from the Zion Lutheran Church in downtown Baltimore. Let's see, I'll flip through here. And this is a type E5 main valve, which has a 5 psi minimum differential, and it has this chamber here because this diaphragm in this model is a rubbery material which doesn't tolerate the high steam pressures. So the water is trapped in here, and this acts like a piston when the pressure is applied here. And it enters this chamber, the pressure enters this chamber, and let's see if I can do it. Pushes up on, normally this is down and it pushes up. As you can see, the spring is pretty well worn away from leaks and failures, and this valve stopped working many years ago. And you can see some details of the construction there, where it's threaded together. And there's something which is to stop the steam from entering here, or steam from going through here and going in and going into this chamber and eroding that, rusting that out. So this normally would not be here. Normally this, on the regular E series, this is stainless steel. I don't happen to have one of those. So, as I said, the pressure enters here and pushes down here and opens the valve. Let's see if it open up the, let's see. Adjusting spring, when compressed, forces pilot valve to open, as we discussed. And here's the diaphragm here separating the spring pressure from the inside of the valve. And they've got, you know, these seemingly 8 million bolts. This is 1/4 28 thread, and I've real pain in the ass getting this apart. And let's see, connecting tubing connects fluid from pilot to main valve diaphragm and bleed port. Ah, that's right. So the pressure goes here, opens the valve, and also some of it is bled away through here. Now, if you take this off, which I think I can, bear with me. All right. And I gotta work that out. There would normally be an orifice there, but as you can see, it's not there. So if that little, and it's just a hole, and if that little hole gets clogged, then the pressure does not bleed away when this shuts. So what happens is the valve sticks open and pressure continues to apply. What's supposed to happen is that when this starts shutting down, the pressure bleeds away, and it's supposed to then cycle down. So that's one of the maintenance items that you have to watch out for. Is there are other videos describing how to differentiate the various problems, but that's a classic failure, is that tiny little orifice gets filled with schmutz and the device malfunctions. So let's see. When pilot opens, fluid flows through pilot faster than it can escape the bleed port, creating a loading pressure which forces the main valve to open. As I understand it, the loading pressure is about 3 psi. So we just need 3 psi here, and this will stroke this valve fully open. And there are various port sizes. There's normal port and then full port. And this can come off here, and there's a high pressure gasket. And let's see, you can see where the gasket material would be. Thank you very much for your tolerance on this. I hope this is useful information. Now, the other point is that right here is piping from downstream, usually several pipe diameters away. A pipe is fed into here, which then exerts a pressure upward on this diaphragm, counteracting the static spring pressure, and cycles this closed. And as this closes, the pressure bleeds away, and the spring pressure then pushes down on this. And so that is basically the analog feedback loop, which maintains the pressure differential. So let's see if we can get that, see if they spots that better. Pilot faster than me, and loading pressure to depth. Delivery pipe and control line. Control line which goes here. Delivery pipe and control line are now being filled with fluid through the main valve. As delivery pressure, yellow, rises, it overcomes the force exerted by the adjusting spring here. And this in turn allows main valve to throttle just enough to maintain the set delivery pressure. If the demand ceases, pilot closes, allowing the main valve to close, affecting a dead end shutoff. And so usually the other thing where you can get a clog I've seen is right here. This area here can fill with stuff, particularly if you don't have a good strainer system. And I've seen that cause issues. And that's really it. This video has gone on for quite a while. I hope it has proven at least interesting, and perhaps even helpful if you've ever run into one of these in some basement in a city with a district steam system. I thank you very much for your support, and I'm going to sign off now.